In this video, we'll be looking into MTH106, or you call it Math 106, and the topic we'll be talking about in this video is integration. So these are the subtopics we'll be looking at under these topics. This integration is for underlevel students offering MTH 106, or probably you call it MTH 106. That is mathematics, and the course code is 106. So this integration will also be useful for student of grade 10 to 12 or SS1 to 3 students offering further mathematics, A-level students, those writing JUPEB, IJMB, Cambridge, and NAPTEP A-level. So kindly stay back to watch this video till the end. Now let's start with the first subtopic, which says integration as inverse of differentiation. Now let's start. What is differentiation? Differentiation comes from something like this, whereby we're given a function of x, which is y equals to something like 3x plus 2. So you can be asked to find the derivative of y with respect to what? To x. Or probably say you should find if they give you the f of x, then you are asked to find the derivative, that is the dy dx. Sometimes they can actually call it y prime. Y prime, that's the first derivative, and so on. So finding dy dx from this, is something like this: dy over dx equals to what? Something like nx n minus 1. So if you find derivative of something, then it's going to be in this expression. So for this one now, it will be something like dy over dx is equals to 3. So that will be the answer for that. But this time around, we're talking about integration. Integration is just the inverse of this differentiation. They're like word and opposite. So the symbol for integration is like this, something like this. Is the symbol for integration, and the integration, like I said earlier, is like an inverse of differentiation, whereby if you're given a function such as y equals to 3x plus 2 as well, and you're asked to integrate, how will it look like? To be something like this: integral of 3x plus 2. So this is how the question will be written to you, and then you have to indicate it that it's with what? Dx with respect to what? To x, because the unknown, the alphabet we have here, let me use that term. The alphabet we have here is x, so it's going to be dx. What about if we have this thing like this as integral of 3u plus 2? So remember that one is going to be with what? Du, that is with respect to what? U. So, and the general term we use to integrate is something like, whereby for this now, the x will be equals to that will be x n plus 1 all over n plus 1. So note this expression. This is like a general expression we use to integrate any function. X n plus 1, whereby n is any integer. N can be any integer, that is any numbers you can think of in mathematics. So just take this is just like an introductory aspect of the course, integration as an inverse of differentiation. So let's move to the main thing. The main thing here is now the second subtopic, and that indefinite and definite integral, and then the properties of integration. So this is the indefinite and definite integral. But before that, look at the properties of integration there. Rules for integrating common function. So we have 4 rules there. But before I go into those rules, before I explain those rules, then let me just explain what indefinite and definite integral is all about. Look at this symbol again, this and this. For an indefinite integral, indefinite integral will just look like this. But for a definite integral, it will have both upper and lower limit. Upper limit will be like, let's say 4, whereby lower limit, let's say like 2 or 1 or 0 or 3. Anything below 4, that is what we call lower limit. It's going to be here. After integrating an indefinite integral, at the end of the answer, you will just put plus c. After integrating in front of the answer, just put plus c. But after integrating this definite integral, you're not putting any plus c. That's just the difference. So don't worry, we'll get to an example whereby you understand this thing clearer. So now let me explain the rules for integrating common function. The first rule is constant rule. Constant. Look at it. Integral of k dx. Integral of what? K dx. What is that k? K means constant. And what is constant? Means any number, any ordinary number. This time around, there's no x, there's no nothing. It's just ordinary number like 1, 2, 3, 4, 5, 6. So let me predict any number. We have this as okay, integrate 7. You now put dx, that is with respect with what? With x. What is your answer? Your answer will just be 7x. Just 7x. And remember that if you are differentiating, if you have to differentiate y, like you should differentiate y. So dy dx for y, and assuming y is 7, let's say y is 7, and you have to differentiate y. I'm now talking about differentiation now. You have to differentiate y, and y is 7. What will be your answer? Your answer will be 0. Hope you remember from the principle of differentiation. We are dealing with indefinite integral because this guy did not have any upper and lower limit, as you can see. So you have to add plus c to your answer. And that is how we have it as kx plus c in that place. Let's look at the second one, which is power rule. Power, you know what's power? Anything is power something. Let me give an example again from that. Integral x. Let me use any value. Let me say my x is let's say 3x. Let me just use that. And n, that n you are seeing there is also an integer. It means an integer. An integer means any number you can think of. So let me just assume that my n, let me predict, let me just assume is let me use 5 dx. It means with respect to its x. Remember that if this place is u, therefore this d will be related to what? With u. It will be u. What I'm trying to say is that if this question comes like this, integral of 3u5, remember that whatever I'm going to write here will be what? Du. Take note of that. So if you have to integrate this based on the power rule, you know it has power. As you can see, the power here is 5. So what will be the answer? And how are we going to go about it? We're going to say dx will be equals to, you can actually put dx, you might not put it. I like putting dx here, but some people do not used to put it. It will be equals to 3x 5 plus 1. You add 1 to it, all over 5 plus 1. That is the meaning of that expression in the power rule. And if you furthermore, that will be 3x6 over what? Over 6, whereby 3 here 2, 3 here 1. So after that, 3 here 2, 3 here 1. Then after that, you are now going to have it as 6 plus 6 over 2. Looking at the third rule, which is logarithm rule. So that logarithm is you have to integrate 1 over x with what? Dx. So the same thing. Even if it is, like I said earlier, even if it is integral of 1 over y, it will be dy. If it is integral of 1 over k, it will be what? Dk. That is with respect to with k. So whenever you are asked to integrate this, so your answer is just going to be ln x plus c. Ln x plus c. That's it. You have to put ln. Although some people used to call it log e x plus c. Some people say just also, or you just call it log x plus c. The best thing to use is ln x plus c. The same thing with this, that will be ln y plus c. Why am I putting c? Because it is an indefinite integral. The same thing with this. This is what? Ln k plus c. So that's the meaning of that rule. And the last rule we have there is exponential rule. Now, if you are given a question like this, integrate exponential kx dx. The exponential is this e. Then what are you going to do? this function you have here, this value you have here, the k, then you are going to integrate it. You are going to integrate it. So once you integrate it, then it's going to be 1 over k. Like it's going to be an inverse in an inverse proportion. So 1 over k e, then you divide all this value back plus c. When we get to example, you are going to get this thing clearer. I'm just trying to give you an overview of what is rule for integrating common functions is all. Now let's go to example. Now let's look at these examples. First one say we should integrate x is power 17 dx. How are you going to be about that? You can actually say that rule go with what? Power rule. As you can see, power rule. So the solution to that is to just be, actually I like writing dx first in front like this before I now write my answer in front. That will be x 17 plus 1 all over what? 17 plus 1, and that's going to be x 18 over what? Over 18 plus c. That's the answer for that, following the power rule. The other one says that we should integrate 1 over root x dx. That's for the b. So for the b now, 1 over root x dx. So I like writing dx in front here. Or before I write dx, let me rearrange this question. If I write what? Dx. This integral can still be like this. It can be in this form, such as root x is power minus 1. Root x is power what? Minus 1. And remember that roots or radical, say the same thing as 1 over 2, power of 1 over 2. So this thing can still be written as integral of what? X is power 1 over 2, everything is power what? Minus 1. You get that? I have not started the integration dx. I have not started the integration yet. So now if I should proceed by what? Opening this bracket by doing what? By multiplying this minus 1, this 1 over 2 with minus 1. So I'll be having it as my integral. Still the question is going to be x is power minus 1 over 2 dx. So if I now have it as x is power minus 1 over 2 dx, then now I can now integrate, because I have reshuffled or I have rearranged the question in a proper way. So integrating that will now be dx equal to x is power minus 1 over 2 plus 1 all over minus 1 over 2 plus 1. So minus 1 over 2 plus 1, that is what? 1 over 2. So my x will now be with power 1 over 2 all over what? 1 over 2. You can leave it like this. You can continue your solving by what? By making this your 1 over 2 a square root back. Something like this. This will be equal to the square root of x all over what? 1 over 2. So continuing from here now is now going to be root x divided by 1 over 2. So by the time we multiply, by the time we allow these two to come up, that will be root x times 2, and that is 2 root x plus c. So that's the answer. 2 root x plus c. And that's the answer for this day. Now let's move to this c. Now looking at this c now, so you can actually just solve it straight by saying dx equals to, if you look at this c, you see that it's go along with the power rule because they all have power. So now how is it going to be? It's going to be 2x6 over what? Over 6, because of this 5 plus 1 following that power rule. So plus 8x4 over 4, the same thing with that power rule. Then plus 3x3 over what? 3, the same thing with that power rule. Then plus 5x plus c. That 5x is for the what? Constant rule, because 5 is a constant, so we just introduce x beside it because of it with respect with what, with x. So we can reduce this all these integers by what, 2 here 1 and 2 here 3, whereby the x will be equals to x6 over 3, then plus 4 here 1, 4 here 2, plus 2x4 plus 3 here 1, 3 here 1, x3 plus 5x plus c. So that is the answer for that. So this d will be, this over x is for all these numerator. So let's resolve this question. So we'll be able to integrate it by saying, I'm talking about the integral of open bracket x3 over x plus 2x over x minus 7 over x dx. Now only we shovel the question again. Okay, now, so let me now divide. If x here eliminates 1 here eliminates this one, take away this, then we have this like this. So it's going to be integral of x squared plus 2 minus 7 over x dx. Now after having this, we can now integrate. So let me now integrate. If I should integrate, now that will now be the x will be equals to x squared. If I should integrate x squared, that's going to follow the, we are going to follow the power rule. So following the power rule, that's going to be x3 over 3 plus, if I want to integrate to with respect with x, we're going to follow the constant rule. So that is going to be 2x minus, now look at this 7 over x. 7 over x looks like what? Logarithm rule. But let me show you something. 7 over x can still be written as 7 times 1 over x. Mathematics student. So look at this. 7 over x can be written as 7 times 1 over x, whereby 1 over x, integral of 1 over x is what? Ln x. So 7 times ln x, that gives us 7 ln x 2 plus c, because it is an indefinite integral. So now we have this like this now. Now, after having our answer like this, let me now talk about, let me talk about the definite integral. Let me give you an hint on how to go about it. Definite integral, like I said earlier, it is to have the upper and lower limit. So let me assume this question now is we are given in a definite integral. Let's say it has lower limit of 3, upper limit of 5. And for this one, it has lower limit of, let me say, 4 and upper limit of, let me say, 10. And we have to solve this. We actually know that this question, this thing, for it to have lower limit and upper limit is going to be a definite integral. So how are you going to go about it? Now, after integrating this function, 2x to the power 5 plus 8x to the power 3 plus 3x squared plus 5 dx, after integrating it, so we got this, right? Instead of we to put plus c, and we will not put plus c, what are we going to do? This upper limit, we're going to replace it with x. Anywhere we see x, put 5. Then we solve that, maybe using calculator or so. Minus this lower limit of 3. Anywhere we see x here, we substitute it with 3. So any answer we get, then we will now say the answer we got after substituting this 5 from, like we're going to minus the answer we got after substituting this 5 minus the answer we got after substituting this 3. So that is what we're going to do. Any answer we got, then that will now be for the answer for the definite integral. The same thing with this one, to this d. Now look at this d now. When we solve this function, when we integrate this function, we got this answer here, right? So now, if we are solving it in the aspect of definite integral, that means we will not put constant c, we will not put plus c. What are we going to do? We are going to insert this 10 anywhere we see x, then solve it, minus, we insert this 4 anywhere we see x. So our answer, that shows that our answer is in a definite integral. So that is all the things you need to know about definite integral. And what's on the board here is what you should know about indefinite integral. So I'll be stopping this video here, whereby in my next video I will be explaining method of integration. So please share this video, give us a like thumb. You can just go to the comment section and comment that you want the part B of this video. So the part B is going to be method of integration. Though I'll be explaining 3 methods in the part B video. So if you need it, go to the comment section and comment that you want the part B of the video of this video. Share this video, give us a like thumb. Thank you for watching.